Everyone, we are group 4 from tutorial 2 and we are going to talk about the topic with the influence in supply factors as well as input on the economic growth rate GDPs of Da Nang City from 1976 to 2007. And our content will be included theoretical pages, data analysis and result, and then we will fix some errors in the model, and then we will come to the conclusion. Firstly, I want to talk about the theoretical pages with the definition of the GDPs, GDPs as well as the gross domestic product, which measure the market values of the final goods and services produced within a country in a given periods of time, and usually is in 1 year. And it will be given by the formula with the growth rate equal to the GDPs of the research years minus the GDPs of the base years. And compared to the base year, we will have the this formula that which is the percentage growth equal to the GDP of research years minus the GDPs of the base years divided by the GDPs of the base year. And therefore, we can see that the increase in scale and the rate of GDPs per capita will reflect economics growth more accurately. And then I will come to some function of the GDPs and why do we use the GDP to measure the market values. Firstly, it can raise the nation economics by maintaining a certain level of growth and therefore can ensure the development of the economies. And secondly, it can also solve some social problem by creating the basis to set and implement social policies, and then can improve living standard, and then it can protect environment, that are the reasonable exploitation of natural resources and permit creation can contribute to environmental preservation. And last, this can advance education and technologies by creating physical permits to promote higher level of education and technologies. And next, we will come to the factor that determine economic growth on the supply side. We have the function that y equal to function f, okay, now, which is represent for the capital that increase with the investment I, which I depend on savings, and L represent for the labor that depend on population growth rate and labor force participation rate. And then the function F represent for the technologies, depend on the technological change and institutional arrangement. And therefore, we use the population regression function, which is PRF. This function, there we have Y is the output of the economies, which is GDPs. X2 is investment capital. X3 is the population, and X4 is the dummy variable, represent for the economic policies. And next we will come to the second part, which is data analysis and result. We use the data and run it on the eViews, and we have this table for the information of our data. We can see here is the mean, median, maximum and minimum numbers. Means of GDPs is about means of GDPs and population, and capital is the average values, which is equal to this amount that you can see here. And with the maximum amount of GDP, population, and capital are all in the year 2007. And the minimum amount is around from 1976 to 1995. and then we will have I will have a graph to show the relationship among GDPs, capital, population, and economic policies. And as you can see from the graph, the GDPs have the same direction with the capital and the population. And if we apply economic policies, GDP will be decreased. And then we will come to the model analysis and result. And we have already have the function equal to this. And this is the function, and we use the data to run in the eView, and we have the coefficient to interpret. Firstly, the beta 2 equal to 0.434109. As you can see, it a positive relationship between GDPs and capital, and therefore if the capital increased by 1 billion Vietnam dong, the expected values of GDP will also increase by 0.434109 billion. And with the beta 3 equal to 0.007661 is also a positive relationship between the GDPs and populations, and if population increased by 1%, the expected values of GDPs also increase by 0.007661 billion. And we have the beta 4 equal to minus 455.9051, and it means that if there was economic policy, the GDP will decrease by this amount billion. And in this function, beta 1 is make no economic sense, so we don't want to mention it here. And then the last one I want to talk about is the coefficient of determination, which is the R square. The R square you can see here is equal to 0.964281, and it's can be seen that approximately 96.43% of the total variation of GDPs is explained by the variance of three factors: capital, population, and economic policies. And now my teammate Hoàng Ngọc Nhân will talk to you about the next part.
So come to the second part is the data analysis and result. I will do the two tests in this part. So the first test is testing overall significance of all coefficients. In this test, I will test whether all variable has effect on GDP. I will use F statistic so that decision rule is that F stat greater than F critical. As you can see here is that F stat in our model F stat greater than F critical, so that we reject HO. So there is conclude that there are enough statistic evidence that at least one variable have effect on GDP. Now come to the next test is that testing individual partial coefficients. So I will test three variables with the same method using this statistic. With the first variable, I holding population and economic policy constant, where capital has effect on GDP, using two-tailed test. With the HO and H1 is capital has no effect and has effect on GDP. T stat, as you can see here, is greater than T critical, so that we can reject HO. So there are enough statistical evidence that capital has effect on GDP. With the last two variable, I will use the same method. So with the capital variable, I also conclude that there are enough statistical evidence that population has effect on GDP. The last variable, I conclude there is not enough evidence that economic policy because T star is smaller than T critical. Now come to the next part is errors in the model. As you can see in here is the consequences of multicollinearity. There are 5 consequences. The detection is have four detection that are higher R square, but few significant of T ratios. Auxiliary regression, VIF, variance inflation factor, and intercorrelation matrix. But in our model, I just use only 2 methods, that VIF and auxiliary regression method. So come to the first method, that auxiliary regression. So I compare R square in the auxiliary regression and original regression, that so that R square is smaller than original regression. So there is no multicollinearity in this model. Come to the second method, is VIF method. I look at the center VIF and it shows that there is population variable appear the multicollinearity in this model. So there is 3 reasons we choose not to fix this error, because population is variable significant. So if we drop this variable out of the model, so it makes no economic sense. The second is the model is still blue, and the third is it will appear, if we drop this variable, it will appear autocorrelation error. So come to the next part of my partner.
I will continue with my part. So we will fix the second error in the model is a heterostochasticity. So we form a method Y heterostochasticity with cross term. So we have a hypothesis testing. HR is homostochasticity, H1 is heterostochasticity. So we run the eView, you can see in the screen. So we will have a Y statistic is equal to 2.57179. So we have a decision rule if Y is larger than X squared, so we will reject HR. So you can see the critical value is equal to 15.5073. So we compare the Y statistic with critical value, so it is smaller. So we will decide do not reject SR. So for on practical purpose, it can conclude that on the basis of Y test with cross term, that heterostochasticity does not exist in our model. So the third error we will fix in the model is autocorrelation. We will use Durbin-Watson test. We can have a hypothesis testing HO, no autocorrelation, H1 first order autocorrelation exists. So we obtain the Durbin-Watson stat being equal to, as you can see in the eView, is equal to 1.663.02. So at 5% level of significance with L equal to 32, K equal to 3, the lower bound and upper bound as respectively 1.200 and 1.650. So we can see that this stat is smaller than DL, so we will reject HR. We have a D stat equal to 1.63602 is bigger than DU, so we do not reject HR. So we conclude that on the basis of the Durbin-Watson test, that autocorrelation does not exist in our model. So we will come to conclude that after checking 3 error that may have in our model, we can conclude that there is a multicollinearity error. So to detect multicollinearity, we have to use two methods. The first method is compare the R-square between auxiliary and the original regression error. And it haven't detected, but the VIP method, the problem have come out. So however, as we discussed with the three reasons above, we decide not to fix the multicollinearity. And after testing hypothesis and error and give a final regression, we can be seen that population and capital is variable that have the most effect to the model. And the third is economics policy is a variable that do not have so much influence in the GDP. So therefore, Da Nang should increase their investment capital and population with a suitable number so that the workforce can increase and promote the GDP. And however, we will have some limitation on research and expansion. The first is that because of the small number of observations, especially the figures of investment capital before 1987 are too small, which significantly affect the research result, so as well as an actual testing. And the second is that due to time constraint, the model as well as the variable that the term choose have a certain limitation. So this is the end of our presentation, and thank you for listening.